The first type of logical reasoning is called inductive reasoning. In inductive reasoning, we make many very specific observations of the same phenomenon. We can call these empirical facts because they're details, they're minor, or they're very limited observations of the universe. But then if we observe the same thing over and over again, we can generalize from that to a broad conclusion, an idea that the observed phenomena will always happen the way we've observed it happen. We can actually refer to this then as an induced fact. Notice that underlying inductive reasoning, there is a metaphysical claim, a basic axiom that we have to accept before inductive reasoning makes sense. And that's a claim that comes from the ancient Greeks. That's the idea that the universe is an ordered rather than a random system. In other words, what we observe many times today, we're going to also observe tomorrow. We can't prove that with 100% certainty, but in fact, human beings have always accepted this to some extent or another because inductive reasoning has been used throughout time by people. So, for example, in the ancient world, the length of the year was determined by inductive reasoning. The ancients would observe the sun rising in a particular spot, and then they would count the number of days for it to return to exactly the same spot, and they'd come out with 365 days. And then they'd observe it again, and again it would take 365 days to return to that spot. And after a time, they concluded that the sun would always take 365 days to return to that spot, and hence we had the year. Another example that we've talked about is about the agricultural calendar, the idea of reaping the crops at the time of the heliacal rising of the Pleiades. And again, the Greeks observed year after year without any theory of how the earth and the heavens worked. They would observe year after year that the Pleiades rose just ahead of the sun at the time that crops should be harvested, and so that became an empiric or an induced fact for them, an inductive fact. The Egyptians did the same thing when they noticed that the flooding of the Nile was always preceded by about 2 weeks by the rising of the star Sirius that they called Sothis. And again, they used inductive reasoning. We've observed it for the last however many years. Therefore, in the future, it will always be the same way. In modern science, inductive reasoning is used to derive certain scientific ideas. One is the value of constants. So, for example, the speed of light. How do we know that the speed of light is always 300,000 kilometers per second in a vacuum? Well, one reason, the strongest reason we know that is because we have observed it many, many times. And measured it many times in a vacuum, and every time we've measured it, it's come out to be 300,000 kilometers per second, and therefore we generalize, we use inductive reasoning to conclude that it will always be 300,000 kilometers per second in space. The gravitational constant that goes into Newton's law of gravity is another one. How do we know its value? Because we've measured it many times, and we therefore conclude that it will always be the same. We also use inductive reasoning to determine relationships and laws. So, for example, the law of electric charges. How do we know that opposite charges will attract each other? Well, there's no real theoretical reason why they should. We simply know they do because we have observed opposite charges interacting many, 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 many times. Every time we've observed them, they will attract one another, and so we use inductive reasoning. We have a reason to believe that they will always behave that way. Another example we looked at in this course was Leavitt's law. If you remember, Henrietta Leavitt observed the periods of 25 Cepheid stars in the Small Magellanic Cloud. That's a sample of 25. She determined a relationship between the the period of the Cepheids and their absolute magnitude. And from that, she used inductive reasoning to decide that all Cepheids everywhere will follow the same relationship that the 25 Cepheids she observed in the Small Magellanic Cloud will also observe. Since then, we've added many, many more data points by observing more Cepheids. And so far, so good. The relationship seems to hold true. Now, from that, we can sort of decide, can inductive reasoning ever give us 100% certainty? Can we be absolutely sure that sometime in the future, two opposite charges will suddenly repel each other? Can we be sure, 100% certain, that we won't find a Cepheid variable that follows a different relationship? Well, the answer, I think, obviously is no. To know for sure that something always happens, we would have to observe it how many times? We'd have to observe it every single time that it ever has happened and ever will happen. And obviously that can't be done. So we can never have 100% certainty with inductive reasoning, but we can get a high degree of certainty. And how do we do that? Well, we make more observations. The more times we observe something, the more certain we become that it will always happen that way. And that's the idea behind inductive reasoning.